Okay, let's talk a bit about the outdoor WLAN deployment and how the weather can affect the deployment of WLANs outside, uh, such as mesh networks or also outdoor bridge links, right? So the outdoor Wi-Fi, I mean, there are some weather conditions that need to be taken into consideration, such as lightning. That is number one, right? So usually indirect or direct lightning impact can cause damage to the WLAN equipment, right? Any kind of impact can damage the WLAN equipment for sure. What needs to be done is, we should be using lightning arresters. Lightning arresters should basically be used, right, for the protection of these devices against the current. Solutions such as lightning rods, can be used, or copper or fiber transceivers may also be used to protection against the lightning strikes. And this is very common in hilly areas where you see a lot of rain happening. Lightning can be a cause of concern in those areas for the Wi-Fi networks deployed outside. The other and probably a common one is wind. Now, because of the long distances and with the highly directional antennas are very susceptible to the movement or shifting caused by winds. So highly directional antennas, these are very much susceptible to uh, you know shifting caused by the wind blowing. So even the slightest of movement, since they are very high directional antennas, they have a very narrow beam width. Now even a slight movement in the antenna can cause the RF beam to be aimed completely away from the receiving antenna, and that's really going to cause a lot of problem, right? Which can interrupt the entire communication altogether. So little bit of movement of a high direction antenna can cause the entire communication to come down. So that's why in high wind antennas, what we do is, instead of, I mean, a grid antenna is typically more stable than a parabolic dish. So try to use grid antenna. These are both high direction antennas. Grid antennas are little more stable than the parabolic dish. So avoid using parabolic dish in areas where there are high wind expected. So when you are deploying a network or troubleshooting a network, these things are supposed to be kept in mind, before you go ahead and do that. Anyway, the third one is, of course, water. Areas where we expect more rain to happen, snow to happen, fog to happen. There are like two unique challenges that come up, So basically, rain, fog, and snow. These three things can cause issues. Uh, First of all, we have to make sure the outdoor equipments, WLAN equipments, are or must be protected from water, from exposure to water, right? And also, water damage is often a very serious problem with cabling and connectors, right? APs are fine. You got to make sure the APs are not getting, not really being hit by water, or that they're not damaged. But and connectors cables and connectors can be damaged very easily, and with water, and this can be a very serious problem, right? So we want to make sure cables and connectors are checked regularly in areas where you expect a lot of rain to happen. Okay, there are basically some weatherproof protective cover also that come for the antennas to prevent them from water damage. So you got to have weatherproof covers for antennas. to make sure that there is no water damage on the antennas as well, right? I think this is what for the three reasons. The fourth one is the air stratification. So let me write that down, is air stratification. Okay, so a change in the air temperature at high altitudes is known as air stratification or air layering. Okay, change in temperature at high altitudes is called air stratification. Now, changes in the air temperature can cause refraction. We all know it can cause refraction. Okay, which basically means bending of light, bending of the RF signal. Refraction is, let me write that down, bending of RF signal, right? So over long distance point to point links, this can actually cause a lot of misalignment and performance issues. Okay, this can over long distance point to point links, it can cause misalignments and performance issues, right? So that's something which needs to be kept in mind. The next thing is the UV and the sun exposure. Okay, UV and the sun exposure, that also has an impact on the Wi-Fi network. Let's see how. Okay, so UV rays and ambient heat from rooftops can damage cables over time if proper cables types are not used, right? So especially on rooftops where the sun can be really harsh, we might want to check the cables and connectors carefully. We want to make sure we regularly check them, and because this can cause a lot of damage to the cables and connectors, the ambient heat, right? Because in some areas in India, the temperature can go all the way up to 47-48 degrees Celsius, which is too high and too hot. You got to make sure you have the right cables and the right connectors in place, and there's some sort of a shielding on them as well, so that they don't get affected by the UV or sun. But yeah, in some scenarios I have seen the cables being destroyed or cables being really not working properly because of the sun exposure to them. So yeah, just make sure you keep all these things in mind when you troubleshoot a mesh network or a bridge network or a bridge link between 2 points, anything outdoor deployed. All these things are very valid. All these variables are very much valid for all the outdoor deployed networks, for example mesh and outdoor bridge links, right? So anyway, keep this in mind. I'll be sharing one more chapter with you, and in those chapters I'll be creating I think a couple of videos, if I'm not wrong, where I'll talk about my experience, and I'll also try to uncover some myths that we follow in the Wi-Fi troubleshooting world, and how we can save precious time, and with the right steps taken at the right time, we should be able to save a lot of precious time, and have the turnaround time done very fast. So basically make sure we reduce the time the network is down, and I'll be sharing all those points in the next coming chapter, right? So see you then. Thank you.